Hello, today we're going to be solving systems equations by using Desmos. This is probably going to feel a whole heck of a lot easier than some of the methods we've used like substitution or elimination, but it's still important to know how those methods work so that way you know if you can trust the answers that Desmos gives you. It's always good to know the processes behind something before you learn how to just throw it into a calculator. So, if we're solving using Desmos, which you are allowed to do from here on out on any assignment, any quiz, the state test, etc., if you already have the equations, you just type them into Desmos exactly the way you see. That's what we have going on in these first two problems. So let's try that out. Like I said, we are just going to chuck these directly into Desmos exactly the way they are written. So for my first equation, y equals -3 divided by 2 to get that fraction, arrow over to get x out of the denominator, minus 2. It kind of moves around while you're typing, but eventually you get a red line, or maybe your line might be a different color. The color is not important. To do the next equation, I just click into the space underneath and type in the next equation, y equals x plus 3. So we can see here that Desmos is solving this by graphing. Remember that when you're solving by graphing, the way we find our solution is finding where the lines meet. Desmos is kind enough to highlight that point. Any gray points you can click on, and Desmos will tell you the coordinates for it. So the coordinates for where those lines cross is at -2, 1. So our solution to the system is -2, 1. So where the lines cross is our solution. You can just write your solution as an ordered pair as usual. Let's try the next one. Again, we already have the two equations, so we can put those directly into Desmos. Type in the first equation, -3x plus 5y equals 27. Click underneath, type in the next equation, 7x minus 7y equals -21. If you find the gray point where they intersect, that is your solution. Click on it. Desmos will give you the coordinates. Since the two lines cross at 6, 9, that means 6, 9 is the solution to our system. So if you're already given equations, it's pretty easy. Just type them into Desmos exactly the way you see them. Don't do anything to them. Type them in exactly the way you see them. It is also possible to get no solution. So I'm going to just kind of draw what that looks like for you here. We talked about this before with graphing. No solution looks like when you have two lines that are parallel. They never cross, they never intersect. And so Desmos won't highlight an intersection point like you see here. We can also have infinitely many solutions. Which means that when you graph them, the two lines are going to overlap. They're going to look like the same line. It's kind of hard to draw here perfectly, but your two lines be overlapping each other. It would only look like one line in Desmos. It would be infinitely many solutions. Most of the time, though, you get an ordered pair. The last two are word problems. So in the last video, last lesson, we were talking about how to set up word problems. Now we are actually going to set up the word problem and then solve it. Let's take a look. Amanda and Jill are selling pies for a school fundraiser. Customers can buy cherry pies and lemon meringue pies. Amanda sold 2 cherry pies and 5 lemon meringue pies for a total of $87. Jill sold 2 cherry pies and 1 lemon meringue pie for a total of $35. What is the cost of 1 cherry pie? So let's back things up. We have cherry pies and we have lemon meringue pies. We know how many of each we sold, but we don't know how much they cost. So let's start with Amanda. Amanda sold 2 cherry pies. So it's 2 times however much 1 cherry pie costs. Let's call that X. And 5 lemon meringue pies. So 5 times however much a lemon meringue pie costs. We don't know that. Let's call it Y. And it was a total of $87. So equals 87. Let's do the same thing with the information about Jill. Jill sold 2 cherry pies. So 2x is the cost of a cherry pie. And 1 lemon meringue pie. So plus 1, y is the cost of a lemon meringue pie. For a total of $35. So equals 35. You could solve the system by elimination if you would like, or much easier, much faster is going to be to solve it in Desmos. So now I'm going to take those two equations and type them into Desmos. I need to get rid of my old ones first, though. All right, so typing in the first equation, 2x plus 5y equals 87. 2x plus 1y equals 35. It looks like I only have one line here. You may need to zoom in or out, especially when you have bigger numbers involved. So I'm going to unzoom here. My lines do intersect at the point 11, 13. So Desmos tells us that we get the point 11, 13. But this is a word problem. Let's think about what the word problem is actually asking for. The word problem is, what is the cost of one cherry pie? The cost of one cherry pie was x. And so we are only going to answer the x part because they only ask about one thing. So the cost of one cherry pie is whatever our x coordinate is. So we say one cherry pie costs 11. And then what is our unit here? Money is measured in dollars. So one cherry pie costs $11 is the answer to this problem. Sometimes they will ask you about both numbers, but since they only asked about cherry pie, we had to know that cherry pie was x, and then label our answer with the correct units. And get rid of these equations before we do our last problem. Last problem is a two numbers problem. Remember that when it's two numbers, just say that the numbers are x and y. What two numbers have a sum of 133 and a difference of 29? So what does the word sum mean? Sum means addition. So if I add the two numbers together, it equals 133. Since my two numbers are x and y, that means x plus y equals 133. Difference, remember, means subtraction. When I subtract my two numbers, we get 29. So my second equation is x minus y equals 29. We have our equations written. We're almost finished. To finish this off, we just need to put the equations into Desmos and figure out our solution from there. So top equation, x plus y equals 133. Bottom equation, x minus y equals 29. You can't see either line, so zoom out till you can see them both. Since we have that 133 there, we have to do quite a bit of zooming. Where do the lines intersect? Lines intersect across at 8152. So we get the ordered pair 8152, but since it's a word problem, I don't want you to write the ordered pair. I want you to write what the ordered pair means. What we are trying to find is the two numbers. So you can just say the two numbers are, what are they? First number is 81, second number is 52. And that answers our question here. So again, if they give you two equations, just type them into Desmos exactly the way you see them, find where your lines intersect, and that is your solution. Write it as an ordered pair. If it's a word problem, you'll probably need to come up with the equations on your own first. From there, type your equations into Desmos, find where your lines intersect, double check if they want one number or both numbers and which one they want. Like for instance, with this one, they wanted only x. For the last problem, they wanted both numbers. And then label your answers with the appropriate units. That is it for systems in Desmos. Have a fantastic day.